Okay, restaurant. Let's see what is there in this question. The pressure P, volume V, and temperature T are measured for a fixed mass of gas. T is measured in degrees centigrades. Okay. The graph shows the variation of PV with respect to T. The mass of the molecule of the gas is 4.7 10 per negative 26 kg. State the unit for PV in fundamental SI unit. So first question is that you have to find the unit of the physical quantity, that is PV. So we know it from the topic of thermodynamics that PV is actually equal to work done. Like work can be found with the help of PV. So we know that it should be joule, which is Newton meters, isn't it? And we can clearly create a unit out of it. And let's see how are we going to do it. Now PV. So P is the pressure. We can write pressure as force per unit area, and V is the volume. So we are just writing it as V. Now we are going to substitute the units there. So force can be written as Newton, volume will be meter cube, and area will be meter square. Overall it is Newton meter. Clearly Newton meter is equal to joule, so I told you that this will be equal to work done. Like PV is the formula, general formula for the work done. So definitely the answer like will be joule. But we want to derive it only in the fundamental units. Joule is not a fundamental unit, it is SI but not fundamental. Fundamental means there are seven fundamental physical quantities. You want to derive the unit only in those terms: kg, meter, second, like Kelvin, like that. Okay, so let's see. Newton can be written as like force. Force is m into a. So Newton will be written as mass into acceleration is meter per second square into a meter. That's it. So this will come out to be kg meter square per second square. This is the SI unit, and we can write like, you can write like s minus 2 also. You can write like kg meter square divided by second square, also one and the same thing. This will be our answer. It's a very simple question, so we will not be going to the mark scheme as of now. Let us move to the next question and see what we do. Deduce using the graph whether the gas acts as an ideal gas or not. Okay, so it's not given like it is a thermodynamical process or something, and this is not from the optionals, so I will not be going into details there. So the only thing is that this is from the topic 3, it means. So in topic 3 there is no condition, so PV is equal to nRT, that's it, like this. Clearly n and r, like it is given that the mass is fixed, it means number of mole is final, and r is the universal gas constant, so nr is constant. Clearly for the ideal gas PV is directly proportional to T, and that should be a straight line, and that should be passing through the origin. When T is 0, PV should also be 0. That is the thing that we have to see. Okay, so if we consider that, that does not like look like that, isn't it? You clearly see this is 400 here, 400, but it is not 0 on the y-axis, and on the x-axis it is shown 0, but it is not 0. This is degree centigrade, and we are talking in the terms of Kelvin. So basically when you extrapolate this curve, it should reach 0 Kelvin temperature, and it should reach 0 pressure, 0 volume, everything should become 0. That is why we call it absolute 0. Okay, so it will be extended, and obviously it can be because this value is very big, which is like 400 Pascal something, and this temperature is also 0 degree temperature is kind of 273 Kelvin. So there is a space there, and it will be passing through origin, no doubt about that. And it is a straight line, uh, which is having the constant slope. So definitely this is an ideal gas, no doubt about it. So this is also done. Now see, calculate in grams the mass of the gas. The mass of the gas. Okay. So the mass of the molecule is given. The mass of the gas. So PV divided by T is equal to N into R. R is also constant. We can take R to the denominator, and we can find the number of mole of the gas from this equation. Let's see. PV, we can choose this point, like this is an exact point here. PV value will be 5 into 10 raised to power 2, that is 500, and the units are all SI. Pascal is like SI unit, and the meter cube is also SI. So 500 divided by R, universal gas constant is 8.314, and T is the temperature, that is 60 Celsius. So it has to be converted into Kelvin. Yes, this is the number of mole. Now we want to find the mass. So number of mole can also be defined as like the mass of the gas divided by molar mass. So the molar mass is not given, by the way. How are we going to find the mass? Uh, okay, so mass of one molecule is given. Okay. So what we do with the help of this number of mole, we find the total number of molecules. So total number of molecule, it will be equal to number of mole multiplied by the Avogadro's number. So this is the number of mole that we find here, and we multiply it with the Avogadro's number to find how many number of molecules are there in the chamber, in the gas. And the mass of one molecule is given. We multiply the mass of one molecule with the total number of molecules that we have, and that will be equal to the total mass. So clearly this multiply by Avogadro number, multiply by this. So I will not be doing this thing. We will go to the mark scheme and see if the explanation given is exactly same. Let's see. Yes. So in the first case, yes, the unit is kg meter square per second square. Very good. Now this, the graph shown is a straight line. Expected graph is to be a straight line. The intercept will be at minus 273 degrees centigrade, that is 0 Kelvin. Even that is written here. PV by T for the two different point, it is coming out to be constant. It's like that. So we can clearly prove that yes, it is an ideal gas. No doubt about it. Now moving to the next. So first we will find number of mole, that is PV divided by RT. When you multiply it with the Avogadro's number, then you find number of mole. You see, number of mole multiplied by Avogadro number is the total number of molecules, multiply by mass of one molecule will give you the total mass of gas. Exactly same thing that I told you. And you can also use your calculator, go back to the video, you find the answer, and you would be getting the answer as 5.1 gram. This is how we do it. Now moving to is there any other part? No, there is no other part. Okay, dear students, so this is the question number 2 for this question paper. Thanks for joining the YouTube channel. Please share the video with all your friends. Tell them to join this channel again. All the best. Bye. See you in the next video.